Syed Hoda from Syed we've been recognized by Fortune magazine and by CB Insights, one of the top AI companies in the world, leading the charge. We're one of 3 IoT companies using AI in a really interesting way. Having said that, I'm about to offend all of you. And I apologize in advance, but there's liquor afterwards. You'll feel better. Nobody outside of Silicon Valley, nobody with a P&L cares about AI. Nobody cares. There's a lot of hype and buzz and all this craziness, and people are adding AI to their websites and their brochures. Nobody cares. You're going to waste a lot of money in AI as investors, and companies will be gone tomorrow. It's a flavor of the day. Unless AI solves a problem, a real problem, not one of your slides, a real problem. So an AI recognized company is going to tell you AI doesn't matter. It's a tool for the right job in the right place. And if it's done properly, it's transformational. But if it's done as, arm candy, nobody cares. We think AI is interesting in manufacturing. We only focus on manufacturing. Biggest industry in the world for IoT, and going through a massive change with job pressures, X, Y, and Z. So very, very quickly, that's who we are. We're a San Francisco-based company focused on visual manufacturing. Our customers are big, giant companies that manufacture things around the world, from healthcare to industrial to automotive, you name it. We're in a lot of different, but only manufacturing, and that's it. And that's who we are. But what do these companies do? How is AI helping these companies solve problems? Well, this is the #1 problem that manufacturers face in trying to make better, faster decisions, according to Gartner. Using your data. That's not rocket science, we all know that, but using your data has been very, very, very hard in manufacturing, in particular. And there's more pressure in manufacturing than ever before because of cost and speed of supply chain, additive, 3D, blah, 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 blah. Why is that the case? Because the variety of data problem. We have figured out the velocity problem. We figured out the volume problem. We haven't figured out the variety problem. Variety in a manufacturing plant is wider than anywhere else in the world. The reason why is because over the many, many years, you've got technologies and factories that are 50 years old, 30 years old, 10 years old, Excel spreadsheets, people's handwriting, all trying to talk to each other. And they can't. And therefore, trying to solve multivariate problems in factories is nearly impossible because they're grown up in a univariate world. And that's where AI can help. Trying to solve a very specific problem in a unique way that so far we haven't come across other technologies that can solve it. So back to my earlier statement. If AI can solve a real problem in the minds of people with real jobs in real locations like banks and factories, not Sand Hill Drive, then it has a half-life. If not, it'll be gone, we'll laugh at it in 5 years. So how does AI solve a problem here? Well, back to the variety of data problem. Here's the reality of the world in manufacturing, but beyond that, it's true in retail and other verticals as well. You have data coming in from different sources. And in manufacturing plant, it happens to be things like ERP systems from SAP, historians, PLCs, which are sort of computation for the actual assembly line, et cetera. All these different things in a plant. Not unlike your home with appliances and a hospital with all kinds of devices. Same kind of variety challenge. But what happens is that you have a question. You're wondering, why is this problem happening? For example, my Samsung phone, why is it burning up into flames? That's your question, right? It takes months and often hundreds of people to solve that problem because the data doesn't talk to each other. So somebody said, you know what, let's create a data lake. That'll bring all the data together, and I can now answer these questions. Wrong. A data lake is kind of like, in your home, that junk drawer that we all have. That drawer where you throw all the crap in because you don't know where to put it, and you hate going in there because it's very scary, but it's there and it's very useful. Guess what? The junk in your junk drawer didn't become useful yet. It's still junk if it's in the same location. The questions you can ask your data have not changed because of a data lake. They're just in the same G drive. But it's still same old data. You can't ask new questions. And again, in a lot of industries, the answers to the old questions are changing, multivariate. So how do we use AI to help solve this variety problem? We took the data, the same data coming in, and I apologize for this eye chart, making sure your glasses all work very, very well. Not meant to be a slide that really move this big. But basically, the same data coming in, rather than keeping its old form and sticking to a junk drawer, we actually restructured all the data. Structured data, unstructured data, data from different flavors of technology, Windows, shares, PLCs, etc. We smashed them together. And then we applied context. Context is the magic word. Context is what's missing from raw data and ROI. Context is what tells people, what does this data really mean? What data is important when you're answering a question about quality or productivity or something, safety? So AI helps us do this. Many years ago, we had people, data scientists, doing this. Now, data scientists, there were a lot of studies done from Forrester, from Gartner, IDC. Data scientists spend anywhere from 50 to 80% of their time doing grunt work, cleaning, looking for data, sorting it together. What AI helps us do is automate the grunt work that data scientists do. For example, in the past, a data scientist would actually get the data, clean it up, find the right stuff, sort it out, etc. We've actually learned the process, improved it, and used an expert system to do that a lot more effectively. The next step is contextualization. Every 1 and 0 has to be assigned to something. This one has to do with quality, that 0 with cycle times, that 1 with machine information. Sometimes the same 1 or 0 has to do with many different things. So we use an expert system to very quickly take raw data, give it context. Now, why is context important? Because, let's go back to, I'm not trying to pick on Samsung's battery problem. I apologize for Samsung if you're in the room. But let's say that was the case. Samsung's a battery problem. If I could have, rather than for 4 months looking around for what the heck was going on here, I could have just asked the question, what is the commonality of the phones that are on fire? What's the shared attribute, the correlations, the causes? We would have very, very quickly, in hours, found out that the commonality, because it has context, is that every single phone had the same battery from the same lot of batteries and the same supplier. That's called context. That's what took Samsung months and $1 billion of brand loss to figure out. But instead, if we had context, we can figure this out very, very quickly. That's what AI helps us do. It helps us go from raw data to context, which then allows us to ask new kinds of questions that you couldn't ask yesterday. And those questions are put into a digital twin. So a digital twin essentially is a virtual representation of the physical world. Why that's important is that it allows you to ask questions that are in the frame of the environment. So a digital twin for a factory is both the way physical objects sort of sit together and how they share information and how products flow, etc. We use AI for the analytics connected to the digital twin. What we're using all kinds of AI techniques to figure out what should the algorithms be based on the data that I have. Random forests, etc. That essentially look at the algorithms we're using in manufacturing and saying quality. Here are the algorithms that can point us to a quality problem. If there's a recall problem in an automotive plant, these are the algorithms that can probably best predict what the defects might be. So we're using AI in a couple areas. Make the data useful and figure out what analytics tools to then use to actually solve the question you have with the data. And so back to my earlier statement, nobody in a factory, no BP manufacturing says, gee, what can I do with AI in my plant? No one says that, nobody cares. What they say is, I've got to solve a problem, a quality problem, an efficiency problem, take money out of my product, deliver it faster. Those answers have changed from yesterday, and AI is the way to answer those questions today versus yesterday. So I want to just pause there and leave some time for some questions, or for you to get mad at me for saying that AI doesn't really matter. Either one. Yes, sir.
So this is a general philosophical question, which I got to ask you, I wanted to ask others as well.
Please.
I don't get what the term AI really is. Like what you call data science. Is it machine learning? Is it text processing? What is it that you're really talking about when you say AI?
Yes.
Can you explain what's the difference between AI and regular machine learning algorithm?
Sure, these are all connected words. Don't get lost in the buzzwords. Who cares? That's my answer as well, is who cares? At the end of the day, why does that matter to you?
Oh, it's just that I want to understand when you say AI, how is it really
Yes.
different from
I was joking.
machine learning?
I was joking. My point was that people are trying to find ways to use the word AI in a sentence, use machine learning in a sentence. The difference in AI and some other techniques, so first of all, machine learning and AI, these are cousins. These are like first cousins, right? Here's the point about AI. AI essentially is very simple. I am taking a process, I'm automating it first, then I'm learning how you thought about moving the process forward, and then based on how it works from here on out, I'm making it better and smarter. That's really the basis of what that is. Now, is that a human-based activity or a machine-based activity? It could be either one. That's really how we're using AI in this case. The techniques for AI, there's sort of beginner, intermediate, and advanced. An expert system is actually probably the intermediate. It's kind of like if you're not really good at algebra, triple derivatives will be kind of hard for you to do. So the same way, an expert system is your path. The first step is to have a really good manual process of a smart data scientist. Expert system automates it. Deep learning, which is where we're going next with this thing, makes it smarter over time. Starts to figure out, how do I make this faster? Based on what's coming in, what should I have used instead? So that's what, at a very high level, there are a lot of smart people in this room who can tell you the difference between AI, machine learning, and X, Y, Z. My view is as simple as that. Take something that you've optimized, hopefully first, otherwise it's going to become automating a bad thing. Then you make it faster, you automate it, and then you apply AI techniques to make it smarter and learn over time and make it even better. I think we're out of time. Thank you very much.
Thank you so much.